Hi everyone, in today's class we are going to discuss one medical device, that is pulse oximetry. So I think you might have seen this particular device when you visited any kind of hospitals, even small clinics. So that is today topic, that is pulse oximetry is what is all about. Okay, so let's start with the introduction. What is meant by pulse oximetry? In the name itself, you can guess it. The oximetry is an instrument or device which is going to measure what is the oxygen level. So that is the name indicates oximetry. The pulse, why it is having this particular word in addition to the oximetry, in the sense that is it representing the location where you are going to place this device. Okay, place the component to sense the oxygen. So usually where we will calculate the pulse means we will look for upper extremities, that is our fingers. Okay, so similarly here also we are going to place the component, that is the pulse oximetry device, over the fingers in order to sense or in order to calculate or measure what is the oxygen saturation. So why we have chosen this particular location, in the sense this is the upper end extremities, the blood reach to the extreme end and then return back to your heart for purification. So that is why we have chosen this particular location in order to sense what is the oxygen concentration which is present in the blood. Okay, so this oxygen concentration will give you the values or analysis of how much of hemoglobin actually present in the blood, which is meant to carry the oxygen. So in this way we can easily calculate the hemoglobin content also, right? So let's see what is oxygen saturation. So you know how important the oxygen is, it is, right? So the oxygen is act as a fuel. It is a thing which will make all the organs to function normally, right? So without oxygen no other organs or no other cells or muscles will not have normal function. So oxygen have very high priority. So if we have any oxygen deficiency, the cell will not in active state. So if a cell get affected, obviously tissue will affected. If a tissue will affected, the organs will affected. Slowly all the organs will start to degrade it, okay, deteriorate, and at one point the organ failure will occur. So this how the importance of oxygen will revolve right from cell to organ. Okay, so this is the thing which is very important to ensure what is the oxygen saturation, by which we will come to know the demand and the supply of the oxygen is equivalent. Okay, so if you see each and every organ or each and every cell, it has its equivalent demand of oxygen, okay, for their function to be work properly. So if the demand oxygen is not supplied adequately or enough to the enough amount, automatically the organs will start to perform very slow, or it will start to do some malfunctionality. Okay, so this is the thing we have to like look for. The oxygen demand is always equivalent to the oxygen supply, and oxygen supply is always equivalent to the oxygen demand. It will vary from organ to organ. Okay, so how will ensure that the oxygen demand and oxygen supply, the oxygen supply is given as per the oxygen demand, means by especially by measuring this oxygen saturation. So if you have a very good oxygen saturation, means it is confirmed that your body have adequate amount of oxygen. It's being supplied to the organ which is being which is have some demand. Okay, so what is the normal range for this oxygen saturation is that 97 to 99 percentage. This is for healthy individual or healthy people. So this has to be maintained. If it goes below this, for example 96 or 95, in some cases even you can see the oxygen level below 85 percentage or 80 percentage. In that case, we can easily say that the people are at very high risk. The oxygen deficiency is very more, so slowly all the organs will get deteriorated and will end up with organ failure, and even the brain will not get enough adequate supply of oxygen. The person well goes to, I mean, will go. The person will go to hypoxia state. So this how the things will go on. So the measurement of oxygen saturation, it plays vital role to like avoid any other future like accidents. Okay, so let's see now what is the ratio of saturation, how we will measure this one. So there are two component in the blood, we will we will focused here. One is oxyhemoglobin, another one is deoxyhemoglobin. The blue color here we have light highlighted is nothing but is a deoxyhemoglobin, and red color one is oxyhemoglobin. So these are the hemoglobin part. If the hemoglobin part bind with oxygen, in the sense that it is called oxyhemoglobin. If the hemoglobin part is free with oxygen, then it is called deoxyhemoglobin. So there will be like a different ratio you can see in HL blood and venous blood. The reason is that the HL blood carries a pure blood, so in that case the hemoglobin carries the oxygen, so the oxyhemoglobin will be more compared to the deoxyhemoglobin. In venous blood you can see deoxyhemoglobin will be more compared to the oxyhemoglobin. The reason is that in venous blood there is a more deoxygenated blood. Okay, so that is the reason you have different ratio in different blood vessels. Okay, so the thing is that hemoglobin is the very important thing. It will act as a carrier or messenger. This is the one which will carry the oxygen to the respective place, to the respective targeted cell or targeted organ. Okay, so blood vessel is the pathway through which the hemoglobin will carry the oxygen all the way to the targeted area. So without hemoglobin, the oxygen will not move from one place to another. So the hemoglobin is very important role in the blood, so to carry this oxygen. So obviously if the hemoglobin content is very less, even though if we have enough or good amount of oxygen, there won't be any left out hemoglobin to bind enough oxygen, so that also end up with some problem. So so we have to ensure that we should have good enough of hemoglobin should be available to bind with a good enough of oxygen, to have a proper supplement of oxygen to meet the demand of organ. Okay, so this how the oxygen supplement will take place. Okay, so the ratio of the saturation is nothing but is a combination of deoxyhemoglobin and oxyhemoglobin. If we have 0% means there is no oxygen is being binded with hemoglobin. 50% means you can see the 50% of oxyhemoglobin and 50% of deoxyhemoglobin, and 100% in the sense you have all the hemoglobin part is being binded with the oxygen. So for example, if you have normal values 96 percentage, in the sense in your blood the 96 percentage you can see hemoglobin binded with oxygen, and remaining 44 percentage only it is left out with as like hemoglobin, that is the deoxyhemoglobin. Okay, so what is the working principle of pulse oximetry? In the sense, this is the one simple medical device. It consists of two LEDs light, okay, light emitting diodes. One is for infrared light, another one is for red light, and opposite you will be having the photo detectors. The reason is that why we are using this LEDs light as a working principle as far as pulse oximetry concerned. The thing is that the blood, the component we were discussing, that is oxyhemoglobin and hemoglobin, it has very good optical properties. Okay, so it has since it has very good optical properties, the absorption of light will be very good at different wavelengths. So that is the reason in pulse oximetry we have the input source as a light, so that when we pass the light, because of very good optical properties of oxyhemoglobin and deoxyhemoglobin, and the absorptions will also vary based on their capacity, and from the absorptions we will easily calculate what is the amount of substance, that is oxy and deoxyhemoglobin, present in the blood. So that is a concept which is placed here in the pulse oximetry. So that is the reason we are choosing the two LED lights, because here we are having two targeted one is oxy and deoxy, and both will have different optical properties. One will work well with the red light and one will work well with the infrared. That is the reason we have two lights, and whatever lights is being absorbed, there are some amount of light will be be escape from the absorptions. Okay, so that light have to be captured by the photodetector, then only we come to know what is the level of absorption has been made by the oxyhemoglobin and deoxyhemoglobin. Unless until we don't have like a photodetector, in the sense we can't able to justify or quantify or measure what is the absorptions has been made by the hemoglobin part. Okay, so that is the reason we have photodetector also in the pulse oximetry. So these are the three important components. One is two light source LED light, one is infrared, another one is red light, and third one is photodetector. And again there is a reason for choosing why red and why infrared, in the sense the red light will have the oxyhemoglobin absorb infrared light at a higher amount compared to the red light. Similarly, the deoxyhemoglobin absorption rate towards the red light is more compared to the infrared light. So that is the reason, because of this unique characteristics for the specific red light and infrared light by the oxy and deoxy, we have chosen this component as a light source component in infrared light. You might have question like, though we have n number of LEDs in different colors, green and then UV also there, why we have chosen red and infrared? In the sense, this is the reason, these two particular molecule, that oxy and deoxy molecule, have very good absorption compared to other light wavelengths. Okay, that is, one is red and another one is infrared light. So the calculation for calculating oxygen saturation is that if we get to know the concentration of oxyhemoglobin divided by total number of concentration of oxyhemoglobin plus deoxyhemoglobin into 100, then we come to know what is the oxygen concentration. So the thing is that now we have to get to know what is the concentration of oxyhemoglobin and deoxyhemoglobin. If we know the value of these two, then we can easily substitute the values of those in this formula, and then we will get what is the oxygen saturation. That is the output we will get in pulse oximetry device as like 99 or 95, 96, and based on the person it will get vary. So what is the main motto? In the sense, we have to first measure what is the concentration of oxyhemoglobin. That is the goal of this medical pulse oximetry device. Okay, so in next class we will discuss how we will have a measurement of, and how in what principle actually this pulse oximetry is follow to record or to measure this concentration, and how this concentration is being converted into percentage. Okay, thank you.